A hearty welcome to all the participants for joining the session. And I hope I will reach up to your expectations. So for the next 1 hour, we shall set our mode to making maths everyday maths. So I would call this particular session as let's have an eye for maths. Eventually, let us all realize maths. When I say realize, making mathematics real, okay? Because usually everyone, when we speak about maths, even the children have a maths phobia. And then why? Because there is a lot of abstractness in maths. There is a lot of things that we need to imagine in maths. And so they have a fear for this mathematics as a subject. So, but today we'll have an eye for maths. That is, we will try to make mathematics real. That's why I said realize maths. Okay, as Nicey put it, that from waking up in the morning, from the schedules, the bus timings, there is maths everywhere. So actually maths is real. It's everywhere, all around us. From the time of waking up in the morning to going to sleep, it's maths everywhere. But for the children, how do we make it so useful, so real, and applied everywhere? That's the objective of the session. So to begin with, I request all the participants to just answer one question, that what are those concepts of mathematics that are applied in everyday life? You may use the chat box for the responses. I will request Nicey to read the responses because I cannot see them.
There's one answer, time. Akshita's answer, time, money, arithmetic, addition.
Yeah.
Speed.
Yeah. Very nice. Thank you for the quick responses. Yes, there are many maths concepts that are taught in classroom and are actually useful in real life. Yet there are many that we do not directly use in real life, but indirectly or use it in other subjects, combine it with other subjects, and it becomes applicable in our life directly or indirectly. So in fact, mathematics is very, very real and it is applied everywhere in our life. So making maths. So today, what I'm going to do is I'm going to deal with the concepts that are applicable for the children who are studying from primary grades to class 10th, because these are those foundational years where mathematics is being applied, and we can make it if the base is very strong, if the foundation is very strong, children would know mathematics, they will be able to imagine mathematics, they will be able to understand mathematics, and it would become real for them. So I'm going to deal with the concepts like time, temperature, money, and I also would like to share with you all some easy activities which will enhance their numerical skills, spatial skills, and of course the art of guessing. Finally, children should be able to assume or guess. That is called as estimation. It's a very important thing. When they study mathematics, they should be able to do that. Okay, so moving ahead, the concept of time, how do we make it real? Okay, as we said, from the time of waking up to the time of sleep. So we usually introduce this concept maybe in class 2, but then the concept is developed through the years to the higher classes also. So we could have different set of activities. Observe the time of rising and setting of the sun for 15 days and make a note of it. This could be an activity for a class 2 child. So, you are asking them to observe. The observational skills are improved among the children. You can even put an open-ended question, which you see here: if the sun doesn't rise, this could be in lower classes as well as in the middle school classes 6, 7, 8, or even 9 and 10. And I tell you, you would get such creative and interesting answers from the children that there is definitely an innovation coming up from such discussions. So maths is not about only calculating and doing in the class. You could make it an active classroom through this, okay, by keeping such activities. Then let them observe the sun all through the day. This is a very interesting activity, and when I had done it while teaching for class 9 and 10, they really found it very interesting. So let the children observe how the sun is moving, how the shadow of the child is moving along with the sun. If they keep observing this for a few days, they will be able to realize that what is the time at which a shadow, you know, this is very important. Applying it in real life, where is it, how was the clock made, how was the time decided, how is it made this time, watch. So let them make a sundial and place it in the center of the school. You could even take them for a visit to Jantar Mantar. There are around 4 Jantar Mantars in India. So you can visit and let them see how it was done long, long back. Not only that, it is, you know, time is a concept which should be connected with value. So the present generation, they do not value time. They really need to be made to realize the importance of time. Hence we as teachers must conduct such activities which will educate them on importance of time. Now, when we the present children, the generations are global. Hence, you know, knowing the time about other countries, such a project on time zone for of different countries all over the globe would help them understand the time, that it is not same where the child lives. The time would not be same in the other part of the globe. This concept makes it more real. So, though all these things are not in the textbook, but that should be part of the projects, the interdisciplinary activities that we conduct, which makes the time concept real and useful for them. Along with this, you know, there are certain more things like children do not stick to the work that is given to them, the assignments, the time schedules, the timeline that is given for the assignments, or their own schedules. So by letting them plan their own routine, sticking up to those routines, even if they initially do not stick to the routines and are unable to follow the routines, let them not repent for it. In fact, take it very healthily and improve on the routine and come up to a solution where they can one day say that this is the routine that is workable for me. That is reality. That is actually what they should learn when they learn the time concept. The motive or the objective of teaching them time concept should be that they should be able to plan their own schedules, they should be able to stick to their timelines, and be successful human beings. So definitely such activities would make them more disciplined and they would be better human beings in future. Next concept is the temperature. Of course, in classroom teaching, we tell them what is temperature, what are the instruments that are used for measuring temperature, then what are the different scales that are used for measuring the temperature, but the real life applications. This particular topic, I found it very, very interesting. Temperature is uh, applied in everyday life in so many different situations. We cannot even count. There are innumerable applications of temperature. Just a simple example is a class 5 child, when the temperature is introduced, can simply go for having identifying all the home appliances where temperature regulation is required and write how you regulate the temperature. So let them learn something more than what is there in the textbook. So it is not only identifying the temperature regulation, but how do you regulate the temperature. Not only that, there could be activities, there could be some open-ended discussions. Once yeah, of course, in the textbook it would be there that the body temperature, human normal body temperature is 98.6 degrees Fahrenheit. But then extension of this topic, do animals and plants also have an ideal temperature condition? There could be an open-ended discussion on this. When there are such discussions in the classroom, children become more confident, they learn a lot, do a lot of research, they find out, and that's the learning. That's very important, that the whatever concept is put in the classroom, that is being applied. They are thinking over it. So that's how critical thinking skills would also develop along with this, the concepts. And let them if we talk about metals, then we can always have a visit to a steel factory or a glass factory, or how an ironsmith works or a goldsmith works. How are they working with the metal? What are they doing? How do they mold it? How do they give shape to it? Where is the temperature involved in that? And such real life activities, if they are put into the curriculum, definitely they will understand that temperature is not only this theoretical concept, that definition of temperature, conversion from Fahrenheit to Celsius degree. That's not the whole thing. It is actually applied and in real life in so many different situations. Temperature not only applied here, the most important and very interesting concept, which I thought of myself, why not let them have an interview with their mom on the experience while cooking? How does she know that the food is cooked or the proportion of spices is correct? It's, the temperature, how is it involved in the cooking? Just for an example, let us take the example of a cake. When you make the cake batter, there is nothing that you understand whether it is what kind of cake is going to be made or what is the flavor of the cake. But once it is cooked under certain particular temperature conditions, then the sugar bakes into caramel, and the essence of the cake comes up. That's how they come to know the cake is cooked. So temperature is involved in real life in so many different situations, and there are some very interesting situations also. So you can let the children cook certain items which need different temperature conditions. So these can be different interesting activities. So maths is not only theoretical, it is actually everyday maths. You can also take them to visit to a dairy farm and understand why the milk has to be pasteurized and how it is pasteurized. So there are many such interesting activities which can be brought into the classroom situation, which can be added into the curriculum to make mathematics everyday maths. Of course, nowadays the children are global, so we do not confine ourselves to only one place, and temperature plays a very important role all over the globe. So a collaborative project among the schools across the globe and across the subjects can also be taken up. A geography teacher, a mathematics teacher, and even physics, chemistry, science can be involved into it, and there would be a very interesting concept, uh, interesting project which will include temperature in this, and how the temperature varies from one place to another place, from one country to another country, and as per the seasons, how the temperature varies season why, and how the seasons are different in different parts of the globe. So all these things can be a very interesting collaborative project which makes it very real and actual. Okay, that's how these can be introduced. Next, we come to money, and according to me, the present generation has to know this concept at a very young age. It is very much needed because they should know how responsibly they should take care of this money, because money is everything we say, but whether it is how much useful it is and how it can distract. So both the things the children must know. So if they learn the money concept only as a currency, a rupee, that's not enough. They have to know how to earn or how to use it, how to responsibly use it. So certain activities, of course, for lower grades, you can always give assignments on flags of a country and its currency. But when they come up to higher classes, they should let them know the conversion of the currency country wise, and how it changes, how it is related with the Indian rupee. Not only that, to make them responsible human beings, a saving challenge can be given to the children for maybe fortnight, maybe a monthly saving challenge, or a 2 months saving challenge, or maybe a 1 year saving challenge. So all such activities would make them responsible. So of course they know in the classroom that there is a 1,000 rupee note, there is no coin for this, there is a 10 rupee coin, but that's theoretical, that will not help much in understanding how it is to be used. You can also give challenges like buy maximum items in rupees 1,000, or buy most useful items in rupees 1,000, or help someone who is needy with these 1,000 rupees, or ask them to earn just 1,000 rupees in 1 week. Such challenges will make it real. The concept becomes real. How? Why did they learn money in the classroom, and how they need to apply it in their real life? There is one favorite activity which we do in our school, which we call it as maths fair. Now, here what we do months before, at least 1 month before when we put the maths fair, we collaborate with art and craft teachers, the home science and meal planning teachers, and encourage children to put their stalls. And they need to learn all these things. They need to, some children are talented. So, but some of them, they enhance their talents with the help of teachers. So it is a collaborative effort. So making best out of waste, making some decorative pieces, making some artwork, all these things children make by themselves. They sometimes learn to cook food. They try to make some items which are very simple, which children can do with minimum material. So we let them put their stalls, calculate the resources that they have invested, decide a price, name the stall. They can even design a bill book. And then they have to put the stall in the fair, sell their product. They should learn how to sell their product. And then finally, they need to summarize the profit or loss at the end of the day. Such activities help children to understand at a very young age that making money is not easy, and business works as per demand. They also understand this. And many things that we have realized as teachers is, this is when you realize that there are some very great entrepreneurs coming up when we do such fairs. So this is one of very interesting activity. Of course, when we for classes 9 and 10, we can always have certain panel discussion sessions where we can talk about the careers or the businesses with good financial returns. This can be a very good panel discussion where children do a lot of research, and they also have a lot of things that they know already which they share. And very interesting inputs come up when you let the children talk about what they are thinking about certain topics. And a panel discussion on how important is money in our life. This gives, you will know at that very young age how children think, what is their future prospects, what are they thinking about money. And it's a very interesting discussion that you can find if you go for these activities. Of course, now financial, it's not always the concept, but skill in mathematics. So mathematics is about developing numerical and spatial skills, as I said now, and which are very, very essential. So whether it is time, temperature, money, but then if the numerical skills are not enough, then calculating all this wouldn't be. So we need to create interest among these learners for calculations, for the numbers. So this calendar activity is one activity which I found is very, very interesting. And they children look at calendar every day. Even we look at calendar every day. But if you relate certain numbers, relate this calendar to certain activities related to mathematics, it makes it more interesting. And so if you look at this calendar, it's a simple calendar. I've started with one, which is Sunday, and put the dates on 31. So it's not required that the calendar should always start with first being a Sunday. It could be any day, and still all these things would be applicable. And you can customize this calendar activity as per the topic that you're teaching in the class. For example, if you're teaching odd and even numbers, the calendar can help you. How many odd numbers are there? Even numbers are there, or the prime and composite numbers, or factors and multiples. If you're teaching factors, you can let them write, design a calendar of their own. For these 31 numbers, let them write the factors below that. Okay, so then you can study on that. How many numbers have just two factors? How many numbers have more than two factors? And two is a factor of how many numbers? Or three is a factor of how many numbers? All such activities you can customize as per the class that you are teaching. Not only that, I think it won't be in this form. I'll have to use it in this way. I hope the screen is visible, because
Yes,
I'll be shifting this
yes.
box. Huh. Now what happens in this, I take this 2 by 2 grid here. If you diagonally add the numbers, 1 plus 9 is 10, 2 plus 8 is 10. You always get the same. Move this grid, you can take this one 2 by 2. 9 plus 17 is 26. 10 plus 16 is also 26. You can move this 2 by 2 grid anywhere and you would always find this works. Not only that, it's not only the 2 by 2 grid. If I take the 3 by 3 grid, even then you would get it similar. 10 plus 18 plus 26. That will give you 54. 12 plus 18 plus 24 would again give you 54. 11 plus 18 plus 25 would also give you 54. 17 plus 18 plus 19 would also give you 54. So the calendar has such interesting numbers. You can extend this to a 4 by 4 grid and you would again get the same way. Not only that, if I can reduce this to a 4 by 2 grid, now you can see 2 plus 12 is 14, 5 plus 9 is 14, 3 plus 11 is 14, and 4 plus 10 is 14. So if we do such activities with children, they will find numbers very interesting. Observing and looking at the patterns. So these activities will enhance their numerical skills. Next. Now, when you begin a class, you can always have some interesting games which could act as icebreakers for the class. So, of course, I have given one example here. Teachers must be knowing more such examples. You can always use this as an icebreaker in your classroom. So let them do such exercise with numbers, multiplying it with 5, adding 6, then multiply the result with 4, then add a 9 to it, multiply by 5, subtract 165, and you are guessing the number which the child thought in his or her mind. You know, such activities will make them feel, oh, maths is magic. I'm sure all of you will agree with that. So then they would create their own such steps and they would think more on this. That would create interest in the class. Not only this, there are some fallacies, we call them fallacies. So you can introduce some fallacies in the beginning of the class and create interest for the numbers. So you can see here 49 is equal to 49. 49 can be written as 25 plus 24 or 9 plus 40. Then you can bring 40 to this side and 24 to the other side and add 16 on both sides, and you have 5 minus 4 the whole square equal to 3 minus 4 the whole square. When you take the square root, you have 5 equal to 3. So you can joke with these numbers, enjoy with the children, and make them do more such activities. These are called as fallacies. Not only this, you could even take some questions which are related with mental maths, which are related with competitive exams, which are very interesting, which are real life applicable. So as icebreakers to begin with your class. You can also have a word antakshari. Like we have word antakshari, we could have a number antakshari, which can we can call it as, and give some steps so that that continues again and again and again. So which I have mentioned here, one of them. So there are many such ways you can create interest for numbers. You can use speed maths, like you can ask them to do it fast. A Bodmer's rule question, which can be simply written. It is not necessary that the child has to be in class 6 only to continue with the board mass rule. It could be in class 7, class 8, class 9, class 10. It's an icebreaker. They already know the concept. So how do you increase their speed? So give it again, repeat the concept again. So put it in the classroom situation anytime. The mental maths, the logical reasoning questions, that can be an icebreaker for the classroom. Patterns can always be icebreaker for the classroom. They would feel, oh, it's so interesting. You can see these patterns. Most of you must be knowing, if they are maths teachers, that the numbers behave like this. If there are 2 11s, you would have 2 in the center. If there are 3 1s, you would have 3 in the center, and it goes other way. On both sides, the same digits are there. If there are 4 1s, 1 1 1 square, it would go up to 1 2 3 4, and then the descending order 3 2 1. It's so easy. So they can do calculations so easily. You can see the beauty of maths here in this reflection. So they are so interesting. Such things you would find in many places. You would find many such numbers which have patterns, which follow a pattern. 10 square is 100, 11 square is 121, 12 square is 144, whereas 441 is 21 square. It's just a reflection of that. 13 square is 169 and 961 is 31 square. It's just the reflection. So it's so beautiful. Maths is so beautiful. Numbers are so beautiful. That's what you need to make them feel. And Ramanujan's magic square. It's the most interesting magic square. The Ramanujan's number 1729. Why is it? The anecdotes of mathematicians. You know, all these things when you share in the beginning of the class or at the end of the class, it leaves a lasting impression on the child's mind. The anecdote story of Gauss, a mathematician, when he was in class 3, he gave the formula for the sum to n numbers, how to find it. You know, his teacher, every day when he would enter the class, just would ask the children to count from 1 to 100, total it, sum, find the sum of numbers from 1 to 100. Doing this every day, you know, Gauge was one of the student in the class, and he came with the formula that if you take 100 into 101 upon 2, you would get the answer. You don't have to add all of them. You know, that's how the mathematicians are born. So maybe there is a mathematician in your class, maybe there is an Einstein in your class. So if you give such activities, definitely you would enhance and come to these creative answers. Ramanujan's magic square, if you take it, this is his date of birth, 22/12/1887. That's the date of birth of the great mathematician Srinivasa Ramanujan. And he created this magic square. If you add in any way, diagonally or row wise or column wise, you would always get the answer as 139. Not only that, even the central 4 numbers give the sum 139. Even the 88 plus 10 plus 25 plus 16 would give the same sum as 139. So if you do such activities in the classroom, it would 100% definitely create interest in numerical skills. It will enhance numerical skills and create interest for numbers. Moving on, the next is the spatial skills. I say these are to be developed, spatial skills, because you know, when we say point, point is a dot. What is it? You have to make it real, make it visible for them. It has no length, no breadth, no dimension at all. How do you imagine? So as we say, cell, atom, all these, they are not visible. Okay, so when we magnify it, it is visible. But actually, point is that small unit which has no dimension, no length, no breadth. So we have to make it visible for the children. What is a point? And when we take so many points together, what we get is one-dimensional line. So we call it as set of points, where you will introduce the topic locus if you want. If you are teaching class 9, you could also add it with locus. Or if you are teaching the lower classes, you could just leave it here to make them understand that if we put too many points together, we get a line. It has one dimension. It either has length, or we call it as and length can be measured in centimeter, meter, and so on, a one dimensional. Now, if we have set of points, if we say locus of points, then there are many different figures that are formed, many different shapes that are formed with different conditions. So make it visible for them, make it real for them. How is it formed? If you make them, now we have so much of technology with us, we can always use technology to make them understand this. So making them understand different shapes. Then if we have a line, we take too many lines together, and then that's how we get a two-dimensional plane. It could be a rectangle, it could be many other different figures, it could be a triangle, it could be square, it could be a different quadrilateral. So all these things we can make it real and visible for them by showing it to them now. And of course, if we have so many planes together, rectangles put together, we always get a three-dimensional object, and that is space. It has three dimensions: length, breadth, height. So we can make it real and visible in this way. But there can be many such activities related, and class wise you can customize as per the class. So you can even have simple activities for lower classes, like looking for shapes around you, looking for patterns in the buildings, monuments, looking for these patterns in nature, which will make it very relevant to them. They will feel why they are studying, why they are understanding it. And there are many interesting patterns in nature. There are many interesting patterns in monuments. You can make so many different patterns, tessellations. All these things can be added when you're making geometry real and visible for them. Extending to mensuration, which is area and volume. So when we say one dimension, we say length. When we say two dimension, the space occupied by that particular object, which is of two dimension, is called area. And when we extend the area one over the other, we place the same object, same plane figure, we get a three-dimensional figure. And the space that is occupied by the three-dimensional figure, how do we measure it? That is called as volume. Okay, so it is about measuring these geometrical figures. So relating these geometrical figures with the other concepts of mathematics makes it more real. Why are we studying all these? Area, volume, the geometrical figures. So there are many interesting activities which you already must be doing in the classroom. Some of them you can see here. So you could even prove Pythagoras theorem, you could even prove concepts like limit, you could even prove geometric progressions using these area and volume concept. Of course, identities we always explain in the classrooms using the area of a square, area of a rectangle, and arranging it. All these activities make it more interesting. You can also see here, when we are able to find volume of a cylinder as 3 times volume of cone, we could always extend it to finding volume of a cube, which is 3 times volume of a pyramid with a square base. So extension of whatever is given in the textbook can be added up here. Now, mensuration has many, many real life applications. Finding the surface area, marking a school playground, marking the basketball court, marking the football court, all this is mathematics. Bring it to classroom situation. Let the children do this. Let them measure the ground, let them measure the areas, let them mark it, and that's how you can make them understand how this mathematics is applied in real life. Finding to calculate volume of milk, of water, and other. Then calculating the area, this which is applied, of course, in the agriculture, in the fields, even for make constructions, civil engineers. So of course, once a child masters mensuration, area and volume, they are going into the field of design, which is a very relevant field now. It's a very popular field. So how they need to understand that amount of paint required to cover a certain surface area. So where is the surface area involved? It is involved in this making, covering the floor with the carpet, the area and volume is involved. So make them do these activities, let them do it in the real life situation, in your classroom situation. Maybe you cannot add every of your class with activities, but definitely monthly basis you could have one of these activities which are relevant to the topic, so which will really make them feel that yes, mathematics is real, it is applied here. In fencing a garden, they use perimeter. When you put tiles on the pavement or on in a particular construction, the tessellations are applied there. When you have to cover certain area which is dug, the volume of sand that is being applied there. So all such things can be applied in real life situations. There are many such activities that are related with mensuration. Then finally I come to this, that the objective of teaching all these topics and making it real is actually they should learn how to estimate, how to understand, how to guess. If I keep these three jars in front of them, a child, if the child has learned volume, if the child has learned milliliter measurements, then they should be able to guess how much is this. If they are not able to do this, then the learning has been left only to the classroom level. The learning is only theoretical, there is nothing practical in it. So this estimation is must. They should learn how to estimate what is the time. With the sun's shadow, they should be able to guess what is the time now. Maybe it may not be exact, but they should be able to guess. They should be able to guess the temperature. They should be able to guess the length of their room. They should be able to guess the volume, the water they drink in the glass. That's the objective. They should be able to guess the height of the tree. They should be able to guess the weight of the fruit that they are eating. If they are not able to do all this, then really we haven't made mathematics an everyday mathematics. It has remained theoretical. So I would conclude saying that maths is more than numbers, and it's a key to understanding our world. Maths develops logical thinking, useful in life and careers, and maths encourages reasoning and abstract thinking, enhancing critical thinking skills. And many top careers need strong maths background. That everybody agrees. And financial literacy is essential for managing money effectively. Mastering maths can enhance overall self-confidence of a child. So let's equip our kids for success with maths.
Some students find it difficult to comprehend word problems. How can we make them grasp the nuances of such questions?
Yeah, thank you for that question. When there is a word problem, you need to break down to certain simplicity, or to make it more simple, break it to more simpler form, and then make it understandable for the child. Now, there are many things in a word problem. Like, for example, if we are talking about cost price and selling price, definitely I don't think that would be a difficult one. But when we talk about percentage discount questions, definitely children would find it difficult to understand. So we need to break it down to more simpler form of the word problem. And maybe the child is unable to identify the unknown quantity in those particular questions. So that has to be made known to it. So if you add a few more read between lines that the problem says, that has to be done from the teacher's end, and hence then it becomes very easy for the child. Yeah.
Thank you, ma'am, for that. We have one more question here. Can mathematics help develop creative thinking skills?
Yes, definitely. Mathematics is all about art, I must say. So creativity is, as I said, I had given some open-ended questions. If the sun is not rising, that is creative thinking skills. Of course, that is, you may think that that is not related with maths. But if I ask the child to just give one circle and make as many designs as possible, I'm sure that is creativity in mathematics. Okay. So there are many concepts. It's not only this that brings creativity. Okay. So even when we ask the children to use a particular area to make certain object, to draw or something, even the Google map, even the map that they draw, without mathematics you can't. The scale that we say, that is mathematics. So the map that they made is creativity. So even when you draw portrait, you have to make those scales. So maths is all about creativity. Without art, art is not possible without mathematics. They are so much related. So creativity is everywhere there, and maths develops creativity. I hope I have answered.
Yes, ma'am. Ma'am, we have another question here. How to balance the portion completion as well as the activity?
Yeah, it's a very nice question. And this is the problem of every teacher, and truly agree with it. But the syllabus is one part, and our ensuring that our learners get what they should get is another. Now you need to combine these to create a balance between these two. So if you have an annual plan, that's what I said, don't do everything activity based. You can initially begin with having a monthly activity. Whatever topic you are covering in a particular month, you plan one activity for that particular topic. Begin like that. And first year, you would have 10 activities. Remember, you have planned 10 months study, 10 activities you have planned, which you are able to manage easily. And it is only this effort, once you did this effort, you are very easy with that particular activity for the next session again. So in the next session, you can add on one more activity each month. And that's how, you at the end of 2 or 3 years of experience of teaching, your classroom is full of activities, and you can easily manage the syllabus as well as the activities. I hope I have satisfied you,
Thank
ma'am.
you, ma'am.
Yeah.
Yes. Ma'am, the next question is, how can we develop computational thinking in new generation students?
Yeah, exactly. That's what numerical skills I said. Computational techniques. They should be very good at numerical skills. We need to create activities. I just, because of shortage of time, I did add Vedic mathematics. That's very important. The shortcut method of calculations have to be taught to children. And the patterns in numbers, there are certain behaviors of certain numbers ending with 5. When you square them, it's very easy to find it. Okay, computer related. Yes. Computational techniques, computer related technique can be enhanced when they are able to imagine, or they are able to understand the logarithms, the algorithms that they write, the stepwise way of answering things. You know, there are certain steps, like if you ask a child, how do you boil water on the gas? Now, when the child gives steps for this, there are certain steps where the child misses. If this happens, what happens? There are missing steps. So stepwise way of doing things and answering things definitely improves computer skills.
Thank you,
I
ma'am,
hope
for that.
I to your answer.
Yes, ma'am. Thank you so much for that. We have another question here. How can we develop creative skills?
I think I have answered the creative skills. The activities, of course, let's not repeat the activities that I have spoken. Creative skills can further be enhanced with some more creative activities or some more collaborative, or if you let the children research on their own after giving a topic, there is a lot of creative skills that are being enhanced. If you give a problem to a child and ask the child to solve the problem by themselves, there are different answers. Always encourage children for not giving the conventional answer and go for an alternate method of doing the same thing. That enhances creative skills.
Thank you, ma'am, for that. We have another question here. Children who develop a fear of maths may not be having a solid foundation in basics. How can we correct this in higher classes?
This is a very relevant question that you have asked. It's a very important question. I would give you some more things, like the Mario game that we see. You let the child make mistakes. Do not ever label the child nor discourage the child, nor say you will never understand this. Such things will remove the fear, because when does the fear come to the child? When you are very particular about whether the child is doing correctly or not. You are not for the mistakes that the child makes. If you leave them free, you do not label them, they will not have fear for the subject. Why does our subject have that fear? It is because of the accuracy that we ask for. This is mathematics is all about accuracy and speed, and if both these things are not there, then that's where the fear comes. When the children are introduced with integers in class 6, when they are introduced with rational numbers in class 8, class 9, when they are introduced irrational numbers, that's when the fear develops. When there are square roots they see, when they see fractions, that's when the fear is developed. So when they come to higher classes, this fear continues, because the fear was not removed in the lower classes. They didn't master it. Now when they come to higher classes, please do not say anything if they are making mistakes. Let them make mistakes. So I say the Super Mario effect. So level 1, they are making this mistake. Let them make it. Correct it. Just correct the mistake, tell them, and then let there be a level 2 for them. Same test, or maybe just modified numbers, same assessment, modified way, and then they would do it better. Once the child is very comfortable with the teacher that she can or he can make mistakes and the teacher wouldn't point out them, makes a lot of difference for the child. And they start loving the subject, they start looking at the subject the way it is, and they will learn it, and the fear would be gone. I have done this with many children. It works.
Thank you so much, ma'am, for that. We have another
Thank
question here. How can we create interest of mathematics whenever all board decreases the syllabus of mathematics and basic of mathematics?
Okay. Yeah. There are certain topics which the board has removed and reduced 30% of the syllabus. Now, the board expects us that whatever we teach should be taught, we should get enough time to teach it in different ways so that the concept reaches the child. You know, even if the syllabus is removed, the basic, a few things they have removed which were already taught in the earlier class or something like that, we can always use it for the while teaching. You can always be out of the book, you can always be out of the box. You need not stick to syllabus all the time. You can always re-teach the basics. You can always visit those concepts which are required in higher classes. So it's only that the question will not come in the exam related to that particular topic if the board has removed it from the syllabus. But the concept is still there. It is there. It should be taught. It can be taught. It is the freedom of the teacher, how the teacher would like to put it across to the child.
Thank you, ma'am, for that. Another question here. It's challenging time for the teachers that some students are very hyper in maths and some of them not at all interested. How to balance these two categories?
Yeah. Welcome both of them. Be happy with both of them. Accept both of them. They will learn. They will do it. Keep a hope. Be doing your work as you're doing, and they will learn it. They will do it. Make them realize how important is maths. Tell them, even if you're not continuing with maths, if you're studying maths up to 12th, you will be good in every field where you will go. You will succeed better than others because your logical thinking, your reasoning power is higher than others. Mathematics develops the brain. So don't worry if you're average in maths. You will do very well in life. They will do it.
Thank you, ma'am, for that. We have another question here. Some students are good in answering the questions orally, but poor in written tests. What can be done? What measures can be taken for those?
Yeah, they are good orally, but they do mistakes in steps. Yeah. Again, I think you can apply the Super Mario effect. Level 1, you made so many mistakes. Level 2, mistakes are reduced. Encourage the child. Make the child realize where the child is making mistake, why the child is hurrying in thinking and unable to put the steps on paper. You can always apply meditation in the classrooms for such children. Calm them down and they will be able to do better.
Thank you, ma'am, for that. We have another question here. In higher classes, some students' basics are not clear. How can we improve it?
Yes, ma'am. I think I have answered just few minutes back. We need to teach them again, because if somebody has left a gap earlier, we cannot keep blaming the child for that. The child is not at a mistake. The gap is left earlier. So we need to clear that gap. So definitely we need to teach again. There's no harm. Maybe the child needs more time with the teacher, or if you could take help from somebody else, parents are always ready to help for their child. So the basics can be cleared always. And as the child grows, if a class 11 child is missing the basics of class 9 and 10, when they are at class 11, at that age, they learn the 9 and 10 concepts quickly. So they would not take that much time as they would take in 9 and 10. So it's always good if you teach again the basics and then move ahead.
Thank you, ma'am, for that.
Thank you.
How to apply computational methods or numerical methods in geometry? Because in computational method, always discusses the error and time.
Okay. Computational methods and numerical in geometry.
Yes, ma'am.
Yeah. I think this is more related with the programming that children learn, the coding that they learn. So, I'm sorry to say that I will not be able to talk about programming, because as a mathematics teacher, I have taught mathematics and I can tell about the mathematical skills, how to develop the numerical skills and spatial skills. So if these skills are improved, definitely I think they would do the computational skills also well. Yeah.
Thank you, ma'am, for that. We have another question here. Can we know a few tips to make primary school children curious to learn mathematics?
Primary school children will not have fear of mathematics, ma'am. Okay, because that's where we are just introducing the concepts. we are introducing numbers. It is same like the other subjects. So there is no question of fear at all, as long as you are putting it across the way it is to be put. Yeah.
Thank you, ma'am, for that. We have another question here. How to increase visualizing power for solving geometrical problems?
Yeah, it's very important. That's why I had shown those slides where you can make children realize what is a point, make it real, visible, how a line is made, make it real, visible, because this is not there in any textbook. You will not find it in any of these the videos that you find. Okay, so you need to create these activities where you will make them understand how a point, if you magnify, you see it like a bead. Now go on putting all beads together, it forms a one dimensional, a line. Make it visible for them, and that's how, then putting many lines together, it forms a rectangle, a plane. A line can be extended in all directions. A plane can be extended in all four directions. So these things, if you make it visible, then they will be able to visualize how these shapes are formed and what are the conditions. Like circle, it is equidistant from every point, from a fixed point that is called as center, and the distance is also a fixed distance. So this particular rule gives me another figure. Now the rule changes, the ellipse rule that I had shown there, sum of the distance is always constant. So if the rule changes, the figure changes. So these things make it visible for them, and they would understand every shape that they see. So that's how you can make it interesting and visualizing, understandable.
Thank you, ma'am, for that. Do we have any more questions? Ma'am, we have one more question here.
Yeah.
Are there strategies or methodologies or short-term courses to help children with disabilities to learn mathematics in a way they understand?
Okay. These are, I think you mean to say the children who are dyslexic and disabilities. Yeah, disabilities, if we talk about physical disabilities, they will not have any problem in understanding maths. Maybe they may be very good at maths. I tell you, it is not necessary a child who has a physical disability would be bad in maths. You will not need a special any other class for teaching that. The child will understand in the normal classroom situation, unless and until there is some issue that they are unable to understand. Only those children would need some special um, another ways to teach. So obviously there are visual ways. There are I think visual would be the best way, and also to some extent kinesthetic ways of teaching mathematics, taking them to the ground, making them do it. These such activities, some children understand when they do it. So take them, as I said, marking the ground, let them do it. Let them play, let them throw the ball in an angle, let them understand angle through that. So they can be done physically, all these things. Let them look at the environment and look where angles are, where are all these mathematical concepts applied. As we said, everyday mathematics, we have done this, making maths everyday maths. I think there are many things that must have made you feel that if we put this to such children who are just not able to understand, if they actually go and do it, they will be able to. The money concept, if they make those art pieces, if they make even a simple make best out of waste, these craft things, and then they sell it, they understand the maths concepts, they will understand the money concept, they will understand the temperature concept. There are many other concepts in maths which can be made easy for them.
Thank you, ma'am, for that. We have one more question here. How the activity helps the below average students to clear the basic concepts, or how to motivate the students through activities?
Yeah. Activities are for such children only who are unable to otherwise imagine. Of course, above average children would only understand through the theoretical way that we teach in the classroom. Rest everyone would understand more by the activities. So the activities will make them realize, make them visualize these concepts. So it is the activities that will help them to understand more clearly. And I have given a list of activities. I'm sure that will help you a lot to apply in your classrooms.